Hello guys, this time we are going to explain about the equations of lines in 2 space and 3 space and the intersection of 3 planes in R3. Before we start, we better know what are 2 space and 3 space. 2 space R2 contains x and y axis. 3 space R3 contains x, y and z axis. There are 3 forms of lines of equations in R2 and R3, which are scalar equations, vector equations, and parametric equations. Scalar equation is also known as standard form, which is ax plus by plus c equals to 0, but this only exists in lines in R2. Another equation is vector equation. For vector equations, they are both in R2 and R3. The vector equation for R2 is x, y equals to a1, a2 plus t multiplied by m1 and m2. The vector equation for R3 is x, y, z equals to a1, a2, a3 plus t multiplied by m1, m2, m3. Let's do an example. So we have 2 points A, 5, 6 and B, 8, 10. We can find the vector equation by finding direction vectors A, B first and putting the point A or point B wherever we want. So now we got the vector equation as xy equals to 5, 6 plus t multiplied by 3, 4. Same process is working under R3 as well in points A, 3, 2, 1 and B, 4, 0, 1. Find the direction vector first and we can get answer as x, y, z equals to 3, 2, 1 plus t multiplied by 1, negative 2, 0. So let's move on to parametric equations. Actually, parametric equations form is the expanded form of vector equation. Let's say we have x and y equals to 2, 3 plus t multiplied by 5, 4 in R2. So we can write parametric equations as x equals to 2 plus 5t and y equals to 3 plus 4t. For parametric equations in R3, we have x, y, z equals to 4, 5, 6 plus t multiplied by 3, 2, 1. So we can write as x equals to 4 plus 3t, y equals to 5 plus 2t, z equals to 6 plus t. After we all know about the forms of equations in R2 and R3, let's move on to planes.
Planes are only existing in R3. Planes also have same 3 forms as lines equations. Scalar form ax plus by plus cz plus d equal to 0 and vector form x, y, z equal to x0, y0, z0 plus x multiplied by a1, a2, a3 plus t multiplied by b1, b2, b3. And parametric form x equal to x0 plus s a1 plus t b1, y equal to y0 plus s a2 plus t b2, z equal to z0 plus s a3 plus t b3. After we know how planes work in R3, we can do the intersection of planes in R3. Before we learn this topic, we better know what is a system. There are 2 types of system. They are consistent system, which has one or more solution, and inconsistent system, which has no solution. Let's start the intersection of 3 planes in R3. There will be 3 options for 3 planes intersecting in R3. Let's say all 3 planes are parallel with each other, or the normals are parallel like n1 parallel, n2 parallel, n3. Within this case, there will be 3 scenarios. First one, all 3 planes are parallel and distinct, so that one is inconsistent system and no solution. Second,